Hello students, welcome back to our Target Prelims 2026 Revision with MCQ series, and this is a new episode of Science and Tech. So as always, we are going to discuss 10 questions and their explanation, and that will help you revise effectively for your examination. So let's begin with the first question for today. Biofilms are often discussed in the context of A. Targeted drug delivery using nanoparticles, B. Assisted reproductive technologies, C. Persistent infections and industrial fouling, or D. Gene editing and synthetic biology. So please take a few seconds, attempt this question, and then we'll come back to the explanation. Done? So this question is talking about biofilms. Biofilms. What are biofilms? So biofilms are structured communities. They are structured community of microbes like bacteria, fungi, protists, etc. So these are actually the structured community of microbes. And these microbes, they actually stick to each other. They are very closely knit. They are sticking to each other due to the presence of a gum-like substance, which is the EPS matrix. EPS matrix is actually that glue-like substance that is holding the microbes together, and it is also a protective film for these microbes, for the community of microbes. Now these can be found on any surface. Biofilms, these are structured communities of microbes that start developing on any surface. Surface could be teeth also, surface could be any medical device also, that could be any industrial device, any pipe or anything basically, where these structured microbe communities can actually come together. Microbes can stick to each other because of the presence of this EPS matrix, and then they will attach themselves to the surface of any object. Now this is problematic because if the microbe community starts sticking together and it starts attaching itself to the surface of any object, it will not do good to anybody. If it gets on the teeth, there will be plaque. If there is any if it is getting on the medical devices, there also clogging can happen. Industries also clogging and fouling can happen. So what is this? It's the persistent infection and industrial fouling. Biofilms are persistent infections and industrial fouling. So they will give rise to infections also. They are persistent. They are these thick films. So they're going to be persistent. They will stick together, and that will lead to diseases, and that will also lead to infections and also clogging of pipes and plaque in teeth and everything of that sort. Okay. So you'll get the explanation, like you'll get the complete PDF on our Telegram channel. You can go ahead and look at the explanation over there. Now we look at the second question. Tokamak is used in the field of A. Safe disposal of radioactive nuclear waste, B. Generation of electricity using nuclear fission reactors, C. Harnessing nuclear fusion through magnetic confinement of plasma, or D. Development of particle accelerators for medical applications. Please attempt this question. Okay, so this is about Tokamak. Tokamak is basically a machine that tries to mimic sun's energy on Earth. So in sun we have nuclear fusion ongoing, that energy is being generated. Now we are trying to mimic that energy on Earth. How will that be done? For that we have this machine, that is Tokamak. So what is Tokamak doing? It is making use of very hot plasma. Nuclear fusion in the sun's surface is generating a lot of heat, right? We are wanting to replicate that heat on the Earth's surface. So for that we are using a machine. That machine is Tokamak. It is making use of super hot plasma. But can you touch that? No. We cannot touch that because it is super hot. So tokamak makes use of strong magnetic fields. Strong magnetic fields, and these magnetic fields actually hold the plasma, maneuver the plasma together. So we are not touching it, no machine is actually touching it. This machine just makes use of strong magnetic fields to control the super hot plasma and mimic sun's energy on earth, because we want to generate clean energy, right? So for that we are making use of tokamak, and for the first time this was used in Russia. So what is tokamak? It is used in the field of harnessing nuclear fusion through magnetic confinement of plasma. Correct? Magnetic fields, these strong magnetic fields are holding the plasma together, they're maneuvering the plasma, they're deciding what to do with it, and we are trying to mimic sun's energy on earth. Okay? So this is the explanation. Moving on to question number 3. With reference to edge computing, consider the following statements. 1. It eliminates the need for data filtering before transmission to central data centers. 2. It requires continuous high-speed internet connectivity to function effectively. 3. It supports data sovereignty requirements by enabling data to be processed and stored close to where it is generated. How many of the statements given above are correct? A. Only 1, B. Only 2, C. All the 3, or D. None. Please attempt this question. It's about edge computing and how is it different from the traditional computing. Okay, so this is about edge computing, which is a distributed computing approach. It's a distributed computing approach where data processing will happen near the source only. Ideally, data processing happens once the raw data, after being filtered, once it is transmitted to the central database, there every processing of data is going to happen, and then we are going to get the desired results. This entire process takes time. So now, in order to reduce the latency, in order to reduce the time that is taken in doing all such things, in edge computing, data processing happens near the source only, near the data source only. Data processing happens. It is not necessary that we keep sending all the filtered data first to the central processor and from there the processing will happen. It does not happen in edge processing, in edge computing. Here we process the data near the source only so as to reduce latency. Okay. So the first statement says that it eliminates the need for data filtering before transmission to central data centers. It eliminates the need for data filtering. No. Data filtering will happen. It eliminates the need to send the filtered data every time to the central database. This need is being eliminated. Only very crucial, very important data will be sent to the central database. Otherwise, all the normal data, general data can just be processed near the source only. But data filtering will need to happen at all times because raw data is not always important for us. For example, if you take the case of a CCTV camera, let's say that is located in your society. Now, it is active 24/7. It is capturing everything, but is all the data important for us? Like for example, if some incident takes place, is all the data important for us? No, we would only want to focus on the data where some movement is happening, movement of vehicles, movement of people, movement of anything. If no movement is happening, absolutely no movement is happening, that empty data or that empty movement data is not really of any use to us. So we will have to filter data. That is data filtering, where we are going to remove all such no movement data and we will only keep the movement data. That is data filtering, and then we are going to process that data and fetch the desired results. So data filtering will always happen, but in edge computing, every filtered data is not necessarily sent to the central server. Okay, so this statement is incorrect. Then it requires continuous high-speed internet connectivity to function effectively. Continuous high-speed internet connectivity. No, this statement is also not correct, because we are not sending every data to the central database, and ideally this is being used in remote locations where the bandwidth is very constricted, because we want to make because we want to process the data in real time, we want to reduce the latency, we want to reduce our dependency on the central database. That is why it can work in very minimal internet connectivity also. We do not require continuous high speed internet connectivity. As I told you, we're not sending every data to the central database or the central server, right? So this statement is also incorrect. It supports data sovereignty requirements by enabling data to be processed and stored close to where it is generated. Correct? Data is being stored, data is being processed locally close to where it is generated. It is reducing the time, it is giving us results in real time, it is reducing latency, and these things are very important, especially in the modern times when we talk of, let's say, CCTV camera footage, or we talk of self-driven cars. Decisions have to be made real time. We cannot really wait on wait for the data to be processed first. It will be sent to the central server, there processing will happen, and there we are going to fetch the results. These self-driven cars also, they have this anti-braking system, so every time there are sensors basically, so these sensors will do real-time computing. They are going to analyze the situation and real-time decisions need to be taken, and at that time, and many times this will also be in remote locations where the bandwidth is not very good, so in those times we see edge computing coming into play. Okay, so this statement is correct. How many are correct? So only one. Moving on to question number 4. Which of the following gases are produced during pyrolysis? 1. Carbon monoxide, 2. Hydrogen, 3. Carbon dioxide. Select the correct answer using the code given below. A 1 only, B 1 and 2 only, C 2 and 3 only, or D 1, 2 and 3. Please attempt this question. Okay, so this is about pyrolysis. Pyrolysis, making use of heat to break something down, to break something into simpler substances, So we are making use of heat. Please note that we are not burning the thing, we are not burning the material, we are simply making use of intense heat, and under the pressure of intense heat, the material is going to break down into smaller, simpler materials. So we'll have solid, liquid, gas, everything coming out of it, and an important gas, syngas, is produced in this process, synthetic gas. So it is carbon monoxide plus hydrogen. So carbon monoxide is produced, hydrogen is produced, and small amounts of, very small amounts of carbon dioxide is also produced. Even though we are not burning this like material up, carbon dioxide in small amount is being produced, because the material that we are trying to break down, that itself will have some amount of oxygen in it. So this carbon dioxide is also generated. It is also produced, though in a very small quantity. Our major gases over here are carbon monoxide and hydrogen. So when we talk about pyrolysis, it is about breaking down a substance into similar substances, into smaller substances, by making use of intense heat, and we are not burning anything, we are only making use of intense heat. Okay, so all the three are being produced. Correct answer option D. Question 5. Consider the following statements. 1. Pluripotent stem cells can differentiate into almost all types of cells in the human body. 2. Multipotent stem cells are found in adult tissues and help in tissue repair and regeneration. 3. Induced pluripotent stem cells are obtained by reprogramming adult somatic cells into an embryonic-like state. Which of the statements given above are correct? A 1 and 2 only, B 2 and 3 only, C 1 and 3 only, or D 1, 2 and 3. Please attempt this question. It is about stem cells and their types. Okay, so stem cells stem cells are those special cells that can basically become any type of cells when we require, when let's say we contract a disease, there is some deficiency, we require certain types of cells. So these stem cells can actually convert into any types of cells. They can become any type of cell. So they are of 2 or 3 types. First, we have the pluripotent stem cells. It is on the potency of the stem cell. So this is actually found in the early embryonic stage. In the early embryonic stage itself, these stem cells are found, and these are going to have the maximum potency. They can actually become any type of cells. So pluripotent cells can become any type of cell when required. Okay, and this is found in the embryonic stage. In the embryonic stage, early embryonic stage itself, in the early embryo, this is found. These types of stem cells are found, and they have the potency, they have the capacity to become any type of cell whenever needed. Then we have multipotent stem cells. These are found in the adult tissues. They are found in the adult tissues, like in the bone marrow. Now they have the potential to become like many different types of cells, but if we compare their potential with the pluripotent cells, then their potential is less. It is lesser than the pluripotent cells. Pluripotent cells can become almost any type of cell. Multipotent cells can also become some types of cells, some special types of cells, but it cannot become some other types of cells. So in potency, pluripotent is higher and multipotent is lower. Pluripotent is being found in the embryonic stage. Now we are talking about the adult tissue where changes have already happened. So multipotent stem cells, they are found in adult tissues. Okay. And then we have a special type, which is the induced pluripotent stem cells. So these are not natural pluripotent, they are not found naturally in the embryo, but we are trying to reprogram something, we are trying to induce the pluripotency. How? They are obtained by reprogramming adult somatic cells into an embryonic like stage. So we are trying to reprogram these adult cells that they start behaving like the embryonic stem cells only, so that they start acting like the natural pluripotent cells. Correct, because it has the maximum potential, it has the maximum potential to convert into any types of cells. So in induced pluripotency, we are trying to induce this pluripotency in the adult cells only. Okay, so the first statement says that these stem cells, pluripotent stem cells, can differentiate into almost all types of cells in the human body. Yes. Multipotent stem cells are found in adult tissues and help in tissue repair and regeneration. Yes. And the third one says they are obtained by reprogramming adult somatic cells into an embryonic like state. Correct. So all the 3 statements are correct. Option D, 1, 2 and 3. Question number 6. Consider the following. 1. Collision of black holes. 2. Merger of neutron stars. 3. Core collapse of massive stars. Which of the above activities are known sources of gravitational waves? A, 1 and 2 only, B, 2 and 3 only, C, 1 and 3 only, or D, 1, 2 and 3. Please attempt this question first. Okay, so this question talks about gravitational waves. Now, what are gravitational waves? In order to understand that and how will these be formed, we must understand what is space-time. So generally, space is something like it's an area where things exist, and time is the time where like when those things exist. But in physics, we do not have space and time. We have space-time together. So space-time is like a stretched rubber sheet sort of a thing, and there we have all these all these different objects. Like for example, if you imagine a planet being placed on this space-time, so it is going to create a curve in this stretched sheet. If we put a heavy mass object over there, it is going to create a dip, right? So it is going to do what? It is going to bend. It is going to bend the space-time. It is going to bend the space-time. So these planets like Earth, if we put Earth over there, it is going to bend the space-time. So this dip that we talk about, this curve that we are talking about is the gravity. So it's like the stretch sheet. Here will be a slight dip if we place a celestial object in this place, in the space-time. So this dip is actually our gravity. The dip that we experience is gravity. And when we talk about gravitational waves, so these waves are nothing but small ripples, tiny ripples that will be created in this space-time. So tiny waves that will be created on this stretch sheet, on this space-time. And how will that happen? So for that, some sort of a collision can take place, some explosion can take place. So you're trying to create waves. So if you just, move that space-time, if you just move that rubber sheet, you put your finger, you try to do something on that, waves are going to be created. So in the general physics sense, when we look at collision, some sort of a collision, ripples will be generated, waves will be generated. Which waves? Gravitational waves. So collision of black holes, yes, they generate gravitational waves. Merger of neutron stars, when merger is going to happen, some sort of an explosion can also take place. That is also going to generate gravitational waves. And core collapse of massive stars. If something is going to collapse, smaller things can come out of it. They can also hit the surface of this stretch sheet that we are talking about. Some sort of an internal explosion again can take place. So these will also create waves or ripples, which are the gravitational waves. So all these distortions or all these activities that we see in this space, they have the capacity to create gravitational waves in what? In space-time. Okay. So which of the above activities are known sources of gravitational waves? 1, 2 and 3. All of the above. Question 7. Macrophages are primarily discussed in the context of A. Hormone secretion and endocrine regulation, B. Generic medicines for high cholesterol, C. Immune cells, or D. Seaweeds used for medicine. Please attempt this question. Done? So it's a pretty straightforward question. It's about macrophages. Macrophages are found in our white blood cells. They are a part of our immune system. So this is discussed in the context of immune cells. So macrophages are like the first line of defenders that we have in our immune system. So our immune system produces antibodies, but macrophages do not produce antibodies. Okay, they are the first line of defense. They are the innate defense that is already present in our body. So what do? They do phagocytosis. Phagocytosis. They engulf the pathogen. They eat up the pathogen or any foreign element that is trying to come in. So it's like acting like the first line of defense. It's not producing any specialized type of antibodies. That is the job of B cells, right? Macrophages are just like are acting like our first line defenders, and they are doing phagocytosis, where they are trying to engulf the foreign material, the foreign invader, the pathogen, whatever it is, and they also produce an inflammatory response. So these are certain first line responses that macrophages produce, and they are a part of our WBCs. Okay. Question number 8. With reference to electric vehicles, the battery passport system relates to A. Digital tracking of electric vehicle batteries across their life cycle, B. Subsidy disbursement for electric vehicle buyers, C. Wireless charging of electric vehicle batteries, or D. Recycling of lead acid batteries used in conventional vehicles. Please attend this question. Okay, so this one is about the battery passport system. Battery passport system. So it's nothing but it's actually a digital ID, a QR code kind of a thing that is placed on the EV batteries, and this tracks the entire life cycle of the battery, like where was it manufactured, what was the year, what all destinations has it traveled. So it's just like a normal passport that we have, passport like humans have. It will cover our life cycle, our like the different timeline, wherever all the different countries that we have traveled to, that will be there. Whenever we have traveled to those countries, what was our duration, all these things are going to be there on our passport. Similarly, we have a battery passport system that is for electric vehicles. It's present on the batteries of these electric vehicles, and it is going to track the entire life cycle of the battery. So this is going to make the process transparent, the entire life cycle of EV transparent. We know when was it manufactured, how much life is left, all the locations that it has been, how much wear and tear has happened. So basically the entire life cycle is going to be tracked. So it is for the digital tracking of electric vehicle batteries across their life cycle in the form of a digital ID that is there. Okay. Question number 9. With reference to the THAAD missile system, consider the following statements. 1. It is designed to intercept short, medium and intermediate range ballistic missiles during their final phase of flight. 2. It can intercept targets both inside and outside the Earth's atmosphere. 3. The THAAD interceptor uses a conventional explosive warhead to destroy incoming missiles. Which of the statements given above are correct? A. 1 and 2 only, B. 2 and 3 only, C. 1 and 3 only, or D. 1, 2 and 3. Please attempt this question first. Okay, so THAAD, or Terminal High Altitude Area Defense Missile System, is a missile system of which country? The United States. It's a missile system of the United States, and it actually intercepts and destroys the incoming missiles in their final stage. So just as they are going to hit the target, it intercepts and destroys these missiles in their final stage. And to destroy the missile, no explosion takes place, like no explosion, any targeting does not take place. There is a simple collision that happens, and the impact of that collision actually destroys the incoming missile. So no explicit kind of an explosion is taking place, something is not really hitting them. It's an impact that is being created by the collision of this THAAD missile system and the incoming missile. So the first statement says that it is designed to intercept short, medium and intermediate range ballistic missiles during their final phase of flight. Correct. Short, medium and intermediate range ballistic missile is what it can intercept and destroy. Okay. It can intercept targets both inside and outside the Earth's atmosphere. This is actually a unique feature, a very interesting feature of this missile system, and this is true that it can intercept targets both inside and outside the Earth's atmosphere. And the interceptor uses a conventional explosive warhead to destroy incoming missiles? No. I told you no explosive warhead is being used. It's a simple collision that will take place, and the impact of that collision is actually going to destroy the incoming missile. So this statement is incorrect. 1 and 2 are correct. So the correct answer would be option A, 1 and 2 only. You can read the explanation in detail in the PDF, but it's a gist of what we already discussed. Question 10. Black mass recovery technology is often discussed in the context of A. Renewable energy generation from waste, B. Recycling of end-of-life lithium-ion batteries, C. Manufacturing of semiconductor materials, or D. Production of biofuels from industrial waste. Please attempt this question. Okay, so this is black mass recovery technology. We are trying to recover something. Recover what? Recover black mass. Now what is this thing? It's actually trying to recover all the valuable metals from the used lithium ion batteries. once the batteries have reached the end of their life cycle, they are not completely to be discarded. They are still having some valuable metals, like lithium will be there, cobalt will be there, nickel will be there, and all these things can be used again. They can be recycled, they can be used again. So we must not be throwing everything away. So what are we trying to recover? We are trying to recover the black mass. And what's this black mass? So when we shred the lithium ion batteries, it actually forms a black powdery like substance, and that powder actually has all the valuable materials or the valuable metals mixed in it, and then the separation will have to take place. So this black mass is the powdery substance which has all the valuable metals. So we are wanting to recover the valuable metals from this black mass. So the correct answer would be option B, recycling of end of life lithium ion batteries. That is taken care of by the black mass recovery technology. Okay, so these were the 10 questions for today. I hope you were able to understand what we discussed over here. You can look at the explanation based on the PDF that will be provided to you. Now let's look at a practice question. The short tandem repeat method is used in which of the following? A, blood group determination, B, DNA identification, C, detection of genetic mutations causing diseases, D, gene therapy applications. Please attempt this question and provide your answers in the comments section. Thank you for watching, and we will meet in a new video.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.